Hello and welcome. My name is Jonathan McClure. I'm going to be one of your presenters today. We're going to give it about one more minute to allow folks to roll in, and then we'll get started. All right, well, welcome. Today we're going to be talking about going faster with microservices, moving from monolithic to cloud native. My name is Jonathan McClure. I'm the Chief Technology Officer here for Mission. A little bit about me, I'm a technologist and a programmer. I still write code more than I probably should. I'm also a cloud strategist and a bourbon junkie. I have deep experience over the years with cloud infrastructure and cloud services, both as a person who has built out cloud services, operated them, and as a user of cloud services. I am joined today by Scott Goldberg.
Hey everyone, my name is Scott Goldberg, Senior Solutions Architect at Mission. A little bit about me is I'm a cloud architect by trade and enjoyment, an automator, so if I have to do it more than once, they'll certainly be automated, and smart home enthusiast. So my house is littered with as many complex gadgets as you could hope for.
Excellent. Well, thanks for joining me, Scott. First, we're going to talk a little bit about who Mission is. So we are a partner of Amazon's. We're an AWS premier consulting and managed services provider. We're based out of Los Angeles and Boston. I'm actually based out of LA, and Scott is based out of Boston. So you're getting representation from both coasts here on the webinar today. And we are a partner to Amazon and also a partner to you, to businesses who are wanting to take full advantage of the power of the AWS cloud. And we do that across the entire spectrum of your needs. So from architecture, right, at the very beginning of your cloud journey, doing migration readiness assessments, helping you build out technology roadmaps, doing POCs to prove out your adoption of the platform. We do migrations and cloud transformations, CI/CD implementation, infrastructure as code, and then we also provide a whole suite of 24/7 services, including monitoring and management of your environment. So if you're ready to ditch that pager and pager duty, you can give that to us, and we'll happily take it for you. And we can even do continuous optimization as well, and cost attribution, cost optimization to save you money. So we're a one-stop shop partner for AWS. And let's get into the content. So what's our agenda for the day? So we're going to talk about microservices, right, and defining what they are. We're then going to unpack a little bit about the benefits and the trade-offs of microservices. What are the challenges that you have when you adopt them? What are microservices designed to solve? We'll go into a couple case studies, including a deep dive into one of our own customers and a little bit of a high level about some of the Amazon's other customers. And then we'll have some time for Q&A. A couple of housekeeping notes. If you actually look in the BrightTalk interface here, there's a section where you can see attachments and links. And in there, there's a data sheet that gives you an overview of Mission, goes into a little bit more depth than I did a slide or two ago. And in addition, we also have two data sheets, one on serverless consulting and one on containers. These are two kind of the bedrock foundational compute pieces for building out microservices, which we'll talk about a little bit more. So you can learn a little bit about our experience and how we can help you from those data sheets. In addition, there's a section for you to put in questions. Feel free to toss those questions in at any time during the webinar. At the end, we'll have a moment for Q&A, and I'll review the questions, and we'll try to get to as many of them as we possibly can. So with that, let's get going. So in order for us to really discuss microservices in depth, we probably should define what exactly they are. So it's a compound word, right, starting with micro, which means small. And it means small not just in the size of the code itself, but also in the scope of the service and the size of the team working on that service. What do we mean by service? Well, a service is an API that provides defined protocols, defined contracts, and defined SLAs. And as a consumer of that service, you can rely on those protocols. You have that contract with the service. So unpacking that a little bit, they are single-purpose, self-contained services with well-defined protocols and published SLAs, and they're designed to be built and operated by small, autonomous teams. And when you take applications and you build out workloads from microservices, you're composing them from a series of microservices that are interconnected, and they're loosely coupled. And we call this a microservices architecture. So you can have a single microservice, and then you have a series of those microservices that you can connect together in a loosely coupled way to compose an application. Now, to get a little bit of a different perspective on what a microservice is, let's look at a quote from Adrian Cockcroft, who is a VP at AWS on cloud architecture strategy. He also has been in industry for quite some time, kind of pioneering building out microservices-based applications. He says that microservices are service-oriented architectures composed of loosely coupled elements that have bounded context. And that is a very dense quote. There's a lot of great content and information in there. So let's unpack it. So a service-oriented architecture, and that means that we have multiple services together in a microservices architecture that communicate with each other over a network. And this will become a key and important aspect of the trade-offs of microservices in a little bit that we're going to talk about. But the notion is that you have multiple services that are connected together, right? They're composed together into loosely coupled elements. And that means that services can be updated completely independently of one another. That means that individual teams can kind of sprint really quickly and continue to innovate within their microservice without impacting the whole negatively. They can be updated independently. You don't have to do these massive monolith releases where you're rolling, you know, hundreds of different kind of features and functions together out all at the same time. You can version them independently, roll them out, and allow them to iterate independently. And that independence is actually protected by what they call bounded context. And that means they're completely self-contained. So if I'm working on a microservice and my team is creating that microservice, I have no need to have any knowledge of the internal workings of any of the other microservices that I may integrate with or that I may be composed with to build out an application. And that creates a great deal of freedom for me as a team, because just like I don't need to have any knowledge of anybody else's internals, they don't need any knowledge of mine. So I can make, I'm free to make decisions as a team that are free me to do the best possible job at meeting my SLAs, my contracts, you know, kind of what I am claiming to offer as a service. So what are the main drivers for people to switch to microservices? Well, you know, there is certainly a trend aspect, right? But I think there are real benefits to consider as well. So the first real huge benefit to talk about is that it accelerates development. And it does this by enabling, you know, you to split out into small autonomous teams that can work in parallel. In traditional monolithic applications, especially at larger companies, you have huge teams of technologists that are working on the massive application all together. And that creates a lot of friction and a lot of overhead. And it means that you can't kind of work in parallel very much, because a change that you make in the monolith may impact another part of the monolith, and you have to be very, very careful. Whereas if you're working on microservices-based architectures, the small teams, Amazon calls them two pizza teams because they're about the size that they can be fed by two pizzas, depending on how big the pizzas are. They're allowed to accelerate development. They can work in parallel and accelerate the overall kind of velocity of your organization. The second major driver is that it can improve your operations, and it can reduce the time to repair, and you're getting the separation of concerns, right? So you can isolate issues down to individual microservices. Now, there may be cascading effects, but generally speaking, you can surface the location of that issue and reduce the time to repair, because now you have a simpler overall kind of architecture to worry about within an individual microservice. It also enables massive scaling, and it does that by isolating those features, right? So if you are working on an individual microservice that has a specific tight focus, then you can really worry about scaling up your particular features and functions. You're not worried about the drag of the whole overall. You really worry about scaling your individual small slice. And because you're a two-pizza team, right, that's this next driver, you can choose the best technology that suits your needs. So if you may have an application that's composed of 20 or 30 microservices, one of the microservices may be using DynamoDB with Java as the programming language, and another one may be using Python and MySQL, right? It really depends. Whatever is the most logical thing the two-pizza team decides is the right technology for their microservice to allow them to massively scale, move quickly, and deliver high quality of service, they're enabled to do that. So small focused nimble teams working on well-defined microservices, they can really be very highly productive and can own their success. They're given that freedom. Now, I will say AWS is one of the best examples of a company that actually uses microservices internally. And a few years ago, they actually published a great kind of article talking about the key drivers that they had for choosing microservices. And you'll see that many of the drivers that they had were very similar to the ones that I called out. So picking the right tool for the job, right? Having the team be able to decide, hey, I think that I need to be using this data store for my microservice because it aligns really well with my needs and my use case. Improving resilience and security. So that's another driver we actually didn't talk about, was security. And when you have these bounded contexts, these kind of more focused microservices, you're able to really lock down your services a lot more effectively. You can lower costs with granular scaling. So instead of having to scale up your entire monolith in kind of massive fashion, you can scale up only the bits and pieces, only the parts of the overall architecture that require that scaling, right? And that can lower your costs overall. We talked about team productivity and creating new compositions. That's actually quite an interesting thing. You can optimize and improve the system and create new applications and new features by bringing in new microservices and swapping them out as well. So the overall application can potentially decide, hey, we are going to try to use this other microservice to swap out this particular part of our overall application to optimize for performance or reduce cost, whatever it happens to be. And it's much easier to do that when you're not having to roll out an entire monolith. Experimentation is also greatly aided and kind of safe failure modes, right? Adopting new technologies because you're not having to say, oh, we're going to have to move the entire monolith over from Java to Python. You can do it in bits and pieces. And you can deploy features safely and quickly. So many of the same drivers at AWS cause them to adopt microservices. But I will say, in order to give you a full and complete picture here, we should discuss the trade-offs with microservices. It's not a total panacea, right? And adopting a microservices architecture does create some trade-offs that you need to understand and consider. So we'll explore three here. And the first one is higher cognitive load. So we talked a lot about monoliths a couple slides ago, and they pack a lot of complexity into a single system. Now, the downside to that is that you don't get that granularity of scaling, you miss out on a lot of the other benefits, but they are pretty easy to understand in many ways because you're not having to worry about an application being composed together of many different systems. But they are easy to understand. A microservices architecture, if you really want to understand the overall system, you have to start thinking about different services, how they relate to one another. And that gets into this next trade-off as well, which is debugging complexity. So if you have a monolith, you don't have to leave the borders of your application, of your fixed system, to do debugging. But if you are adopting a microservices architecture, congratulations, you now have a distributed system. And as we know, distributed systems have very different ways and methods for tracing and debugging and kind of instrumenting them. And that means you have to adopt modern tools and modern instrumentation. Now, I believe that this is actually a trade-off that is completely worth it, because to take full advantage of public cloud in general, you really need to evolve your tools and monitoring anyway, because the mode that you live in is completely different. And the technology is moving really quickly. You need to be able to have things like distributed tracing and modern observability platforms that can really kind of run the gamut from the infrastructure all the way up through application performance management and even out into mobile and kind of web browser and edge monitoring as well. So this does create trade-offs, but I think it is one that is absolutely worth it and will help make your teams more effective and efficient. So the last trade-off is really, it's sort of a difficult one, because at the end of the day, it's kind of unbreakable, right? And that's the speed of light. So in a monolith, all your requests are handled and processed within a single system, and oftentimes they don't even have to leave the borders of that application. They don't have to run over the network. With microservices architectures, a single request coming from a customer may touch dozens of different interconnected systems behind the scenes. And interestingly enough, in the early days of enterprise Java, I actually did a lot of work in that area, and using enterprise Java beans and kind of some of the earlier systems and models for building out kind of applications. And an anti-pattern that I noticed was trying to equate a local kind of function call or method call with a network-bound remote method call or remote object. And this was really common in those early days, and it was a big mistake in my opinion, because you cannot treat remote services like they're local services. It's not the same. When you decompose a monolith into microservices, you have to start thinking about doing things like batching of requests. You need to limit those network-bound calls. You need to think about caching and gracefully handling delays. You cannot overcome the speed of light, and you need to treat the network as something that will fail and will underperform at times. And so this is a trade-off for sure, but what you get out of this is you get more resilient individual bits and pieces. And because your microservice is limited in scope and really focused on solving a particular problem, the kind of set of tasks that you need to worry about when it comes to batching and caching is much smaller. And so you can really focus on doing that in the areas where it's really necessary. So this is a trade-off, but I do think it actually leads to more resilient, higher quality systems. So how do you go about building microservices? The great thing about this is that it's easier than ever. AWS is this incredibly broad and powerful set of services. There's hundreds of services with thousands of features, and many of them can be used for composing microservices. But when we really think about the core compute side, right, where am I going to actually build out the compute for my applications? You can absolutely build out microservices using kind of more traditional approaches, using EC2 with auto-scaling, but many people now are adopting containers and serverless, containers and Lambda. I actually believe they're ideal for microservices for a number of reasons. And the world is definitely easier even from a containerization perspective now because of things like ECS and EKS, which provide full container orchestration as a service, either with the control plane of ECS or with Kubernetes. And if you're using the Fargate launch type, it can reduce your management burden to near zero, right? Because it's a serverless container orchestration. You just upload your container to the container registry, and off you go. Similarly, serverless is becoming a very popular thing in general, including Lambda, which is really the thing that pioneered serverless as a concept. And you can build out significant applications on top of that and glue things together with the Amazon API Gateway, which helps to kind of define, publish, maintain, and even secure, monitor, and scale your microservices and APIs. You can process requests that come in, scale them massively, and have the actual processing of requests from the API gateway delegated out to AWS Lambdas. And then you can pay only for the compute that you use. So these are two great kind of ways to go about it. And I would say there's not really any one right answer here. Many microservices leverage a mixture of containers, Lambda, even EC2, and they integrate things together with the API gateway. So the last thing I'll talk about before we dive into some case studies is that if you start to shift your perspective a little bit on AWS, you can kind of start to see that they've given you a great head start towards building your application. So remember we talked about an application can be composed from a series of microservices. And you only need to build out microservices that haven't already been created or that you don't already have access to. And in many ways, AWS is actually a marketplace of microservices. I had mentioned earlier there's hundreds of services, thousands of features. Let's look at a couple of them. So Amazon S3, it's the original AWS service, and it is a serverless object storage service. You can actually treat it as a data store in many respects now. It's got incredible amounts of capabilities, tagging, you can do S3 select, you can actually query it with Athena. It's a pretty incredible service. In addition, you look at the gateway, API gateway, which we talked about, fully managed API environment, SNS for pub-sub messaging, Aurora Serverless, which is a fully on-demand auto-scaling database. You don't have to manage it at all. You can treat all of these as externally produced microservices that you can compose together to build out your application. So you're just building another service that integrates with these. And that means that AWS is giving you a huge head start on building out your application and a model that you can follow. So I think that is an incredible opportunity for anyone who wants to build out microservices applications. I think a lot of people think, oh, I just need to put everything inside of Kubernetes and that'll get me where I need to go. I think that's missing out on the opportunity to adopt many of these great features and services that are available in the AWS Service Catalog that can really accelerate for you. So let's talk about case studies, both AWS case studies and mission case studies. And I'm going to hand it over to Scott for the mission case study, but I did want to call out really quickly 3 case studies that are on AWS's website. Now, the case study we're going to talk about with mission is for a smaller company, and it's one of my favorite case studies because it really goes into these benefits and talks about how we move from monolith to microservice. But I also wanted to point out that these massive businesses are also adopting, right? This isn't something that is exclusively for a small business or exclusively for a large business. So the 3 examples that I'll call out for AWS are the Washington Post, Coursera, and McDonald's. These are brands that you have certainly heard from and heard about, right? And they have massive workloads. So the Washington Post, they have a fully containerized publishing platform now, and they have over 100 microservices with more than 3,000 containers. So you can absolutely scale microservices-based applications up to a huge scale. And Coursera, they actually were able to move from a monolithic application to a microservices-based architecture. And they saw the greatest benefit in the time to deploy software changes. Before, it was going from hours, and by the end of their journey, they got it down to minutes. And we see this all the time. This is a huge benefit that our customers love to see. And finally, McDonald's, they created their home delivery platform in less than 4 months. So they had a very fast time to market by adopting a microservices approach. And they scaled to over 20,000 orders per second. That's a lot of chicken nuggets, I'll tell you what, powered by AWS. So with that, I'm going to hand it over to Scott, and we're going to talk about one of my favorite customers, Your Call Football. So Scott, tell us a little bit about that customer.
Thanks, Jonathan. So Your Call Football is going to be similar in migration to the Coursera one that Jonathan just mentioned. And so, again, Your Call is a mobile gaming platform that incorporates real football gameplay with fantasy-style fan-sourced play calling. So essentially, the coach on the field selects a play package that gets sent to a mobile application where users then vote. The chosen play is returned to the coaching staff and is then relayed to the players on the field who have to execute it. If the play is successful, then fans earn fantasy points accordingly. So it was anticipated that a large number of concurrent users would be playing the game, and due to the nature of the live sport, no delays could be afforded throughout any of the app experience. The developers had already built a large majority of the app's functionality, but they needed help scaling it and meeting the identified response time requirements, as well as ongoing monitoring and management of the platform to maintain that performance and reliability baseline. So they reached out to Mission for help. So we started with a single monolithic app that met all functional requirements, but suffered from significant performance bottlenecks. The goal was to migrate the individual services that comprise the application to Kubernetes clusters in order to meet that anticipated demand. There was also a tight timeline before the season began, and as the games had already been scheduled, not having the app ready by then was not going to be an option. As you can imagine, the monolithic app and supporting services were plagued by several single points of failure. We configured high availability and/or failover for all services and even migrated to AWS managed services where possible. The environment was also not capable of scaling up and down very quickly enough to meet the demand. After all, the app needed to go from supporting very little to as many as 100,000 users within minutes before a game would start. To combat this, we replaced the monolithic EC2 cluster with Elasticache and Kubernetes. After a good deal of performance tuning, we were able to meet the tight performance requirements and only needed to scale the environment about an hour in advance. Lastly, the company wanted to allow their developers to deploy code and scale the environment before a game, but without providing them access to the actual AWS accounts. So Mission built an automated deployment pipeline with Terraform and Jenkins, and this allowed the devs to be more productive and have the flexibility they needed while maintaining security and cost controls. So this is a high-level depiction of what was built. We created the networking, clusters, databases, and other AWS services using Terraform so that we could quickly make changes to scale the environment up or down for the games while providing some uniformity across environments. We used Aurora RDS for storing user stats and other game data, but the majority of the session and scoring information was stored in Redis and in the queues. In order to isolate the loads, we built multiple clusters and then tuned in on the ideal pod density for each in order to squeeze out some additional performance gain. During the first season, the clusters were built using COPS as EKS hadn't been released yet, but for the most recent season, we migrated to a single ECS control plane cluster with worker node groups. And we got just as good, if not better, performance while also reducing the management overhead for everyone involved. We're now looking at moving additional components of the application to Lambda and Fargate to further improve execution times and reduce overhead and cost. And I think that's it. I think we'll take any questions that you guys might have.
Fantastic. Well, thanks, Scott. I think before we dive into questions, I'll say your call is a really interesting use case because they had kind of struggled a little bit with their existing workload, right? They had built things out in a monolithic way, but we were able to decompose it for them, right? As Scott went through the detail. And so a lot of people are nervous about that. They think, oh, you know, I already have a monolith. I have to start over if I want to build out a microservices-based architecture. And that's definitely not true. You can absolutely evolve and decompose your application, and along the way still reap many of the same benefits. So I definitely wanted to point that out. So let's look at questions here. I've got a couple rolling in, so please keep them coming. We love questions. So the first one is, this is a great one. It actually asks about small teams, and can small teams also benefit from microservices architectures? And the answer to that is yes, right? So, you know, I did mention if you're in a large company and you have this huge team working on a monolith, you can get these great benefits by parallelizing development by splitting into two pizza teams to work on microservices. Now, if you have a monolithic application and you have a small team, you can still do the same thing and you'll get a great deal of benefits, but they'll be more around the scaling and the kind of focus and the ability to choose the right technology for each individual component. And I actually find that bit to be particularly exciting. So, you know, a couple of years back, I was the CTO at a SaaS startup, and we had an application that had a whole series of different functionality that was built into it. One was a kind of the web view, and another one was a full reporting system. And the reporting system we built out in a completely different technology stack, and we interconnected these services together we had a very small team, but we were able to get many of the same benefits because we were choosing the right technology for the job rather than attempting to shoehorn everything into the same kind of technology stack. So yes, you can definitely benefit. Scott, maybe I'll throw this one to you. Tell me a little bit about, monolithic environments. I know there are certainly areas where I would use a monolithic kind of approach versus a microservices, a distributed approach. It's certainly not always the right answer, but maybe unpack that a little bit.
I think it really comes down to networking and bandwidth requirements, right? So for something like this Your Call football case study where everything had to be as near real time as humanly possible, I will say that we did end up with a portion of the voting application itself being deployed on a huge number of EC2 instances, and that was because we couldn't get the networking across the Kubernetes clusters to be fast enough to be able to handle the computational requirements of aggregating those votes. We did sort of, once EKS came out, we were able to kind of solve that problem by combining some of the clusters and things like that. But, there is certainly a use case for maintaining at least a portion of your application potentially in that sort of monolithic approach. But for me, it largely comes down to, performance requirements of the networking.
Yeah, and I think that's absolutely a factor, and it really does come down a lot to your team as well and kind of their comfort level. I think microservices can be a great approach for many, many, many use cases. But look, if you have a very kind of small application, putting everything together inside of a monolith, if you decompose it, you may actually create more overhead than you really need. And there is certainly a time when decomposing makes sense. So if you don't have massive scale requirements, if you have a limited scope application, a monolith can be completely reasonable and easy to scale and run just fine for your particular needs. So I would say don't necessarily have to go overboard, but if you have something that has moderate to high kind of usage, has a large enough scope where you would benefit, absolutely monolith is probably not the right approach. Okay. The last question I see here is, you say that microservices leverage a mixture of containers and lambdas. Can you explain in more detail? Sure. So Lambda is an incredible piece of technology, and I actually personally really love using it, but it is pretty new, right? And there are limitations around what it can do. Notably, there's kind of long-running execution is not a particularly good fit for Lambda. There are things you can do to mitigate that. You can chain things together and have a Lambda, push out to another Lambda, and you can use step functions. There's lots of ways to get around that. But in many cases, especially for long-running kind of services, a container might be a better approach. But that doesn't mean that there isn't a great deal of benefit to handling and processing requests, for example, in kind of rapid succession or in massive parallel using Lambda. So I think it's all about choosing the best tool for the job, and in many cases that's going to involve a mixture. And I have absolutely seen cases where EC2 and autoscaling are used to build out microservices. Now, remember earlier we talked about how one of the big benefits is that a microservice doesn't need to know about the internals of another microservice that it's dependent upon or that it uses or that it's composed with. And that's very true here with the way that the compute is kind of leveraged within an existing microservice or within a particular microservice. So you can absolutely mix these things together. I think in most cases you'll see at least a lot of containerization and maybe some Lambda. And we actually have several customers who are all in on Lambda and their entire application is built that way. So there's no one right way to do it, and I think in many cases you'll find yourself leveraging several different services to get to where you need to go. Anything to add to that, Scott?
No, you nailed it. Awesome.
Okay. Well, I think those are all the questions we have. So I will point out one more time the attachments and links section of the BrightTalk interface. You'll go in there and you can see an overview of Mission, who we are, how you can reach out to us, how you can talk to a smart guy like Scott, and hear how we can help your business. You can also see a data sheet about serverless consulting and containers consulting. And with that, we'll wrap up. Thank you so much for joining us. We look forward to seeing you next time.